The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a mathematical tool. Title of the video, Abacus division, what happens when the assumed quotient is larger than the real quotient. Example, 3588 divided by 46. In the current example, let us demonstrate what happens when the assumed quotient becomes larger than the real quotient. And for this, let us use the same example, 3588 divided by 46. Let us set the dividend 3588 in the right side of the abacus and the divisor 46 in the left side of the abacus. In method 2, in deciding the assumed quotient, we add 1 to the first digit of the divisor, which makes it 5. Ask how many 5s in 35, and by saying 7, we treated 7 as the assumed quotient. Suppose we have treated 8 as the assumed quotient, and in that case, what will happen? The problem itself will tell us that we are wrong, and let us demonstrate this. Let us set the assumed quotient 8 to the immediate left of the dividend. Let us start the multiplication process, and we have to multiply 8 with 4, that is 32. We subtract 3 from the thousands column and 2 from the hundreds column. For that, you have to clear 5 in the hundreds column and add 3 in the same column. Now we are left with 388. In the next stage, we have to multiply 8 with 6 and subtract it from 38, which are the first 2 digits of the remaining dividend. 8 multiplied by 6 is 48, and we have to subtract 4 from the hundreds column and 8 from the tens column. We are stuck here as the remaining number in the hundreds column is only 3, whereas we have to subtract 4. That means we have committed an error, and in this case, it is due to the fact that the assumed quotient is larger than the real quotient. When the assumed quotient is smaller than the real quotient, we can always make adjustments in the problem by adding value to the assumed quotient. However, in the case of assumed quotient becoming larger than the real quotient, one may have to reset the problem and start the division process again. This may take more time, and sometimes the child may lose track of the problem too. The purpose of the demonstration of method 2 is to make a comparison of how different it is from method 1. Though both methods are acceptable, method 1 reduces the possibilities of errors in the calculation, whereas method 2 may become slightly complicated when the assumed quotient is larger than the real quotient. Experiences with visually impaired children reveal that most of them are comfortable with method 1, and therefore in the division exercises which are going to be demonstrated from here on, we will adapt method 1 in selecting the assumed quotient, that is, making adjustments in the quotient and not in the divisor.